Notice that all of the initial conditions are given around the origin. There's actually a reason for that. And I'm trying to think of what the next topic, we might talk about that next class. The reason is, once you go out to infinity enough, it's like with any polynomial. Once you, like, all the interesting things in a polynomial happen around its center, right? Like the curvature and stuff, and then you just get end behavior. The same thing happens for differential equations a lot of the times, especially differential equations, that linear differential equations, which kind of like behave like polynomials. All the interesting things happen around the center, because as you go out to infinity, the second derivative takes over, okay? So the contributions of the first derivative and the function itself become less and less. So you actually get less interesting behavior. And we can zoom out next class and take a look. But if you've noticed a consistency that all the initial conditions are given around the origin, it's because of that, because that's where you get like the interesting solutions that curve. Because the solutions that go out look flatter. All right, but anyway. All right, so problem 4, we're going to solve another IVP. Y double prime minus y double prime minus 8 times y prime plus 17y equals 0. All right, you're sitting in a Calc 4 DiffEq class test. You remember that this is a homogeneous second order with constant coefficients. So the characteristic equation is this. You factor it. The roots are complex. You have you memorize your formula. So the general solution is c sub 1 e to the lambda t cosine of mu. Mu is 1 in this case, plus c sub 2 e to the 4t sine of mu. Okay, and then the derivative is this. This one is a little bit more complex because the derivative is a product rule. And then if you apply the initial condition, I'm cheating here a little, skipping steps, but negative 4 equals c sub 1, because sine of 0 is 0, so that cancels. And then negative 1 equals 4c sub 1 plus c sub 2. So c sub 1 is negative 4, c sub 2 is 15, and you can piece together a particular solution. You can take its derivative and prove that it's equal to that this is true. And then this is the graph. You have it is going to be an exponential. If you factor out either 4t, it is an exponential. So negative cosine of t plus sine of t, if you add two waves, you get a wave as well. Remember, because of sum and difference identities, if you add two waves, you get a wave as well. So you have an exponential times a wave. So it's going to be a wave-like explosion, basically. All right. And the thing that happens is, it takes off pretty quickly. So the interesting thing is around, the interesting behavior is here where it dips, because then, it does go up and down more and more. All right, and then we'll try one more. 16y double prime minus 40y prime plus 25y equals 0. Okay. And then you have initial conditions. So it is a homogeneous, second degree homogeneous equation. Wait. Second degree linear homogeneous equation with constant coefficients. Okay. I kind of wish there was a clever name for it as well for this one, like Euler or Bernoulli, but these ones, so as you've guessed it, there can be second degree homogeneous with non-constant equations and coefficients and so on. And in that case, you basically do what you do to a Bernoulli to get it to look like a linear. You divide out whatever the non-constant is. But anyway, so this is my characteristic equation. You factor it. It factors as a perfect square. Happens to be a perfect square trinomial. So the roots are 5/4 in both cases. So your general solution is this: c sub 1 e to the 5/4 t plus c sub 2 t e to the 5/4 t. This is the derivative. You do have to use a product rule again. You apply the initial conditions. You get that c sub 1 is 3 and c sub 2 is negative 6. You piece together a particular solution, and this is its graph. So you're combining an exponential with a linear. Okay. All right. So separable, linear equations, Bernoulli, second degree linear homogeneous equations with constant coefficients. All right, you know how to solve 4 by hand. All right, so you are set for like the first 3 lectures of a differential equation class, maybe 2 if the class is difficult. All right, so now you're ready to try a few problems on your own. We do have a rather long, right? There's no more B days this week, right? Okay, so we do have a rather long break coming up, so I'm going to make this problem set due on April 20th at 9 a.m. and that'll give me a chance to grade some of the stuff you've been turning in. I've been kind of busy with the algebra stuff. I hadn't had a chance to look at it yet, so I'll definitely look at it and send it back to you. All right, and okay, have a wonderful Easter break.